Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul High School, Solapur. I shall welcome to all of you in the session of 10th Mathematics Part 1st. The topic is Linear Equations in Two Variables Part 3. In this session we are going to discuss on determinant method, that is the Cramer's rule of solving linear equations in two variables, and problems based on this content. Friends, in the previous session of linear equations in two variables, we have been discussed with the following important subtopics. Those are graph of a linear equations in two variables, steps to follow for drawing a graph of linear equations in two variables, graphical method to solve linear equations in two variables, and problems based on these contents. Friends, today we will discuss with determinants. Determinant. A matrix is an array of many numbers. For a square matrix, that is a matrix with the same number of rows and columns, one can capture important information about the matrix in just a single number called the determinant. The determinant is useful for solving linear equations. The determinant can be viewed as a function whose input is a square matrix and whose output is a number. If n is the number of rows and columns in the matrix, remember we are dealing with square matrices. We can call our matrix as n into n matrix. The simplest square matrix is a 1 by 1 matrix which contains just a single number. In the next square matrix is a 2 by 2 matrix which we can write as, in two bars we have to write A, B, C, D, 2 by 2. Here A, B and C, D are rows and A, C, B, D are columns. So degree of this determinant is 2 because there are two elements in each column and two elements in each row. Determinant represents a number which is AD minus BC. The determinant of a matrix A is denoted by det A or det A, that is the determinant A, or simply in two bars within A. Determinants usually are represented with capital letters A, B, C, D, etc. Determinant A can be written like this, and we have to take the first product shown with red color, A into D minus B into C, that is with blue color. So important note you should have to remember that square in this brackets, that is indicating matrix if we wrote like this, and if you write in vertical bar indicating that that is a determinant. So friends, in the short we can say a matrix is an array of numbers enclosed by a square bracket, whereas a determinant is an array number enclosed by two vertical bars. So determinant method, that is the Cramer's rule. Using determinants, simultaneous equations can be solved easily and in less space. This method is known as a determinant method. This method was first given by Swiss mathematician Gabriel Cramer, so it is also known as Cramer's method. To use this Cramer's method, the equations are written as a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. Here you can see that a1x plus b1y plus c1 and a2x plus b2y is equal to c2. Here the first column is x column, the second is y column, and third is the constant column. So after solving these two simultaneous equations, we will get that x is equal to c1 b2 minus b1 c2 divided by a1 b2 minus b1 a2. Therefore you can write that this a1 b2 minus b1 c2 is nothing but a determinant within two bars c1 c2 and b1 b2, whereas at the denominator a1 b2 minus b1 a2 is nothing but a determinant of a1 a2 b1 b2. Therefore now y is equal to a1 c2 minus c1 a2, where at the denominator divided by a1 b2 minus b1 a2. So y is equal to, you can write in the determinant a1 a2 c1 c2 within two bars and a1 a2 b1 b2 within two bars. So friends, we have that d is equal to a1 a2 b1 b2 within two bars, and dx is equal to c1 c2 b1 b2, and dy is equal to a1 a2 c1 c2. So to solve for the variable x, we can write that x is equal to dx upon d, that is c1 c2 and b1 b2 divided by the a1 a2 and b1 b2. At the same time, to solve the variable for y, we will get y is equal to dy upon d, which will be equal to a1 a2 c1 c2 and a1 a2 b1 b2. So let us, some important point to consider when looking at the formulas. The column of x, y and the constant term c are obtained as follows. Y column, which is a1 a2, y x column is for a1 a2 and y column is b1 b2, and the constant column is c1 c2. Both the denominators in solving x and y are the same. They come from the columns x and y, that is d is equal to a1 b1 and a2 b2. Looking at the numerator in solving x, the coefficients of x are replaced by the constant column in red, that is dx is equal to c1 c2 b1 b2. a1 a2 is replaced by c1 c2. In the same manner, to solve y, the coefficients of y column are replaced by the constant column in red color. You can see dy is equal to a1 a2 and c1 c2. b1 b2 is replaced by c1 c2. So friends, let us see the flow diagram for Cramer's method to solve the simultaneous equations. So first of all, you have to write the given equations in the form ax plus by is equal to c. Find the values of the determinant d, dx and dy. Using x is equal to dx upon d and y is equal to dy upon d, find the value of x and y. This is what the flow diagram to determine the solution of the given simultaneous equations. Now let us see few problems based on this. Number 1, find the values of the following determinants. The first is -1 to 7, 4. We are reading the column wise. First column -1 to, second is 7, 4. Here we'll get -1 to 7 to the first product is first column, first term and second term of the second column. That is -1 into 4 minus 7 into 2. So it will be -4 minus 14, that will be -18. Means in short, the value of the given determinant is -18. We'll consider the second one. Find the values of the following determinants, that is 7 by 3 and 3 by 2, 5 by 3 and 1 by 2 in the second column. Friends, we'll write the given thing, 7 by 3, 3 by 2, 5 by 3 and 1 by 2. This is the given determinant. So which will be equal to 7 by 3, the first, into 1 upon 2, the second, minus 5 by 3 into 3 by 2. So the product will be 7 by 6, 7 1s are 7, 3 2s are 6, minus 5 3s are 15, 3 2s are 6. So the answer is 7 minus 15 upon 6, which will be minus 8 upon 6 is the answer. Therefore, the value of the given determinant is minus 4 by 3 after simplification to minus 8 by 6. Now let us see one more problem. Solve the following simultaneous equation using Cramer's rule. 3x minus 4y is equal to 10 and 4x plus 3y is equal to 5. These are the given two simultaneous equations. Equation 1 is 3x minus 4y is equal to 10 and equation 2 is 4x plus 3y is equal to 5. Equations 1 and 2 are in the form of ax plus by is equal to c. So comparing the given equations, we are getting a1x plus b1y plus is equal to c1 and a2x plus b2y is equal to c2. We get a1 is equal to 3, b1 is equal to -4, c1 is equal to 10 and a2 is equal to 4, b2 is equal to 3 and c2 is equal to 5. Therefore, the value of d will be a1 a2 b1 b2, that is 3 4, first column, second is -4 3. So after simplification, 3 into 3 minus -4 into 4. So which will be 9 minus of -16, that is 9 plus 16, which will be d is equal to 25. Second, we will calculate dx, which will be equal to c1 c2 b1 b2, which will be 10 5 minus 4 3, which will be 10 into 3 minus of -4 into 5, which will be dx is equal to 30 minus of -20. So which will be 30 plus 20, therefore dx is equal to 50. dy is equal to a1 a2 7 c2, which will be 3 4 and 10 5. We are substituting the values of a1 a2 7 c2. Now we'll do the multiplication, 3 into 5 minus 10 into 4. So which will be dy is equal to 15 minus 40, which will be -25. By using Cramer's rule, we'll get x is equal to dx upon d, which will be 50 upon 25. So which is equal to 2. At the same time, y is equal to dy upon d, which is minus 25 upon 25, which is minus 1. Therefore, 2 and minus 1 is the solution of the given simultaneous equations. We'll continue with the next problem. Solve the following simultaneous equations using the Cramer's rule. The equations are x plus 2y is equal to minus 1 and 2x minus 3y is equal to 12. Friends, we start with the solution. So the given simultaneous equations are x plus 2y is equal to minus 1, equation 1, 2x minus 3y is equal to 12, equation 2. Equations 1 and 2 are in the form of x plus by is equal to c. So comparing the given equations with the a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. And what we get is a1 is equal to 1, b1 is equal to 2, c1 is equal to minus 1, and a2 is equal to 2, b2 is equal to minus 3, and c2 is equal to 12. Friends, now d is equal to a1, a2 and b1, b2, which will we substitute the values of these 1, 2, 2, minus 3, which will be equal to 1 into minus 3 minus of 2 into 2. So which will be minus 3 minus 4, that will be minus 7, d's value. Next we will find out dx. Dx is equal to c1 c2 and b1 b2, which will be minus 1 12 and 2 minus 3. We have been substituted the values, which will be minus 1 into minus 3 minus of 2 into 12. So dx is equal to 3 minus 1 minus, that will become plus 3 minus 12 to the 24. So dx is equal to minus 21. Now find out dy, which will be equal to a1 a2 c1 c2, which is 1 and 2 minus 1 and 12. So friends, after cross multiplication, 1 into 2 minus of minus 1 into 2, so it will be 12 ones are 12, minus minus plus 2 ones are 2. So 12 plus 2, that is dy is equal to 14. By using Cramer's rule, x is equal to dx upon d, which will be minus 21 upon minus 7. We have been kept the values of dx and d. So after simplification, you are getting the answer as 3. X value is 3. Also, y is equal to dy upon d. The value of dy is 14 and d is minus 7. So the answer is minus 2. Friends, 3 and minus 2 is the solution of the given simultaneous equations. Let us try the last problem. Solve the following simultaneous equations using Cramer's rule. The equations are 2x plus 3y is equal to 2 and x minus y by 2 is equal to 1 by 2. So friends, we start with the solution. The given simultaneous equations are 2x plus 3y is equal to 2, equation 1. The second is x minus y by 2 is equal to 1 upon 2. We'll simplify, the fraction is we'll remove. So multiply both sides by 2. You are getting 2x minus y is equal to 1. It is the second equation. Equation 1 and 2 are in the ax plus by is equal to c form. So compare the given equations with a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. We'll get a1 is equal to 2, b1 is equal to 3 and c1 is equal to 2. And a2 is equal to 2, b2 is equal to minus 1 and c2 is equal to 1. Friends, we'll calculate now determinant d is equal to a1, a2, b1, b2. Substitute the values 2, 2, 3 minus 1. So 2 into minus 1 minus of 3 into 2. So it will be 2 ones are 2 minus 2 and minus 6. That will be d is equal to minus 8. Friends, now we'll find out dx, which will be equal to c1 c2 b1 b2, which will be 2 1 3 minus 1, which is equal to 2 into minus 1 minus of 3 into 1. Therefore dx is equal to minus 2 minus 3, that will be minus 5. Friends, now we'll calculate dy, which will be equal to a1 a2 and c1 c2, which will be equal to 2 2 and 2 1. So 2 into 1 minus 2 into 2, so 2 ones are 2 minus 4, which will be equal to dy is equal to minus 2. By using the Cramer's rule, we have x is equal to dx upon d. The value of dx here is minus 5 and d is minus 8. Therefore, the value of x comes up as a 5 by 8. Next, we will try for y is equal to dy upon d. The value of dy is minus 2 and d is minus 8, which will be after simplification you are getting 1 by 4. So friends, 5 by 8 and 1 by 4 is the solution of the given simultaneous equations. I think I considered here different types of the problems. In the textbook you will get more and more problems. Try for them. So friends, what we have discussed today is determinant, Cramer's rule, that is determinant method to solve the linear equations in two variables, and few problems based on this content. Friends, here are a few problems for you. I discussed today the problems on Cramer's rule, variety of the problems. If similar problems are there in the textbook, that you have to attempt at the home. Find the value of the determinant 5, -7, 3 and 0. Solve the simultaneous equations using the Cramer's rules. These are the three equations. Number 1, 4x plus 3y minus 4 is equal to 0 and 6x is equal to 8 minus 5y. Here you have to convert this into the standard form, that is ax plus by is equal to c. Then you have to attempt 6x minus 4y is equal to minus 12, 8x minus 3y is equal to minus 2. It is already in the standard form. 4m plus 6n is equal to 54 and 3m plus 2n is equal to 28. These are also in standard form. So try these problems at your own. So friends, you should not forget before leaving the session the famous words of Albert Einstein. We shall require a sustainability, new manner of thinking if mankind is to be survived. So very nice sentence. Think over it. If you like this video, please subscribe and share. With these words, I would like to say thank you.